I want to welcome everybody to Fusion Energy Week. And we're on the fourth day now. And you're at our second mini podcast, AI and Fusion Expert Conversations on the Future of Energy. So you're in the right place. And today, I'm thrilled to welcome our featured guest, Maria Ortiz de Zuniga of Fusion for Energy, which is a huge organization based in Barcelona, Spain, but it's part of the overall European Union mission to make fusion energy a baseload energy resource for us all. So first, I'm going to stop the screen share. And I want to, firstly, too, I want to thank Fusion Energy, US Fusion Energy for organizing Fusion Energy Week. And this is actually the second year in a row that Maria and I are hosting, or that I'm hosting and Maria is featured as a guest for an expert conversation about fusion energy. So that's a great momentum to keep up. So we have as our featured guest today, Maria Ortiz de Zuniga. And just a brief mention about who I am. So I'm not, talking in the wind. My name is Paige Donner, and I'm a small business owner. I own IoT Logistics LLC. And I have been communicating about fusion energy since 2021. So I've done a number of series of expert roundtables and conversations. And this is the second year, as I just mentioned, that I'll be communicating on these topics for Fusion Energy Week. And this year, we're really drilling down on AI and fusion energy, which is why we're featuring Maria today. So Maria, you have a great role at Fusion for Energy. I believe your actual title is Head of Unit for Project Engineering, CAD, and Technical Data Management. So you work with the Fusion Technologies and Engineering Department of Fusion for Energy. But because you're a European-based organization, why don't you give us some context and tell us more about Fusion for Energy and its greater role, in the European Union regarding fusion energy, and then tell us a little bit more about your exact role in the organization, if you will, please.
Okay, so hello, Paige. It's great to be here again for a second consecutive year. Thank you very much for having me. And as you correctly said, so I'm Maria Ortiz Zuniga, and I work at Fusion for Energy. And Fusion for Energy is the European organization responsible for delivering Europe's contribution to ITER. So what does this mean? I mean, one of the main tasks of F4E, as we call it, as an acronym of Fusion for Energy, is to work together with European industries, SMEs, and research organizations to develop and provide a wide range of high technology components together with engineering, maintenance, and support services for the ITER project. As probably most listeners today will know, the ITER project is the largest international collaboration we have today. And the aim is to have a stable pulse of plasma, right? If we were to simplify it quite a bit, but that would be it in just a few words. So F4E, on top of the European contribution to ITER, also supports fusion R&D initiatives through what we call the Broader Approach Program, which is which is an agreement signed with Japan and prepares for the construction of demonstration fusion reactors, also called DEMO. F4E was created by a decision of the Council of the European Union as an independent legal entity and established in April 2007. And I've started working here in September 2007. And it was established for a period of 35 years. Its headquarters are in Barcelona, but we also have offices in southern France, in Cadarache, where ITER is being assembled in Germany, in Garking, and in Japan, in Naga and Rakasho. So at F4E, as you can see from its mandate and the main objective of the organization, we work at the intersection of large-scale engineering and digital innovation, which is what I'm partially doing. Obviously, I'm not alone in this, and many of our colleagues are in different units collaborating to make this possible. But that is increasingly including artificial intelligence, right? So we started already 7 years ago, more or less, when before this became a buzzword, before we started seeing AI in the media all over in the news and before this hype started happening, right? Um, and for us, it's really a practical tool that helps us manage complex technical data to support engineering decisions. So we're not replacing any engineers, we're just letting engineers do their engineering work and make sure that we can give engineers as much information to be able to take the right decision, which is, in our case, to ultimately deliver ITER components more efficiently and reliably. In parallel, I'm also chairing the ITER AI joint project. So that is the international collaboration to align how AI is used across the fusion ecosystem and all the parties or domestic agencies, as we call them, that are involved in ITER. And there, what we see is basically how can we use AI in all areas of an organization, not just engineering, to turn it into something concrete and useful in a very demanding industrial context to de-risk and potentially accelerate the ITER project.
Okay, wow, that's a great overview. And you kind of touched on a few of the points that I was thinking the next questions might get to. But because that was a nice overview, I think it'll still be helpful to drill down on a couple of those points. Namely, like for example, how is Fusion for Energy, specifically using AI as part of Europe's contribution to ITER? You touched on that a bit, but like what exactly are you doing on that consortium that you're chairing? That sounds fascinating. And does it relate to supply chain as well as engineering? Does it relate to operations? Like how is AI being applied?
Okay, so at Fusion for Energy, as I was saying before, our role is very concrete, right? So we are responsible for delivering Europe's contribution to ITER. What does this mean? Well, depending on the component, we're either just manufacturing. In other cases, we're starting earlier in the project life cycle phase, so we can be qualifying and then manufacturing. In other cases, we're even designing, right, and then qualifying, procuring materials or qualifying materials even sometimes, and then delivery to the ITER organization in southern France. So that means that we also need to manage all the associated technical data across the full life cycle of the project, right? So in that context, what we started seeing is that because we many times building first of a kind components or designing or manufacturing or qualifying, there was a point where there's little prior knowledge to what we have to do, right? And it was scattered all around. So statistical results or statistical data can only help you up to a certain point. And when you are trying to basically get out of that world where we usually have experience, statistics don't always work that well, right? And that's where AI comes in. So AI is able to learn from a limited amount of data what the human brain would have learned, right? So it's in welding, it's like having a super welding engineer or expert, right? Tell you, well, the next weld is going to fail, or be careful with that one, change the position, or change basically the time of the day at which you're going to do that weld, right? So for us, It wasn't something that we did on our own. In the first cases, it was a very exploratory kind of work where let's say we informed our suppliers we were going to do this, but because we didn't know what the outcome was going to be and we didn't want to distract them from where they work, we just said, we're going to do this with your data and we'll let you know how it goes. And the truth is that as this started working better and better, our suppliers actually asked if they could get involved. And they could also learn from this process, right? And use our AI model. So it became a tool to support the industrial delivery of our components. So it wasn't just abstract research, it was very concrete, real engineering work and in that industrial environment, right? So one of the main areas where we apply AI is technical data management. So that is, we produce, because of the size of our components, some of these components are manufactured for 10 plus years, and that generates millions and millions of data. And because many of our components are safety critical, the level of traceability, so basically the logging of all the data, is something that we had already present in our process, right? That was already there. But one thing is having the data and just leaving it in a documentation repository or in a PDF. And another thing is really using that data and converting it into information and therefore knowledge, right? And that's what changed with AI. So we started using those enormous volume of engineering data. So anything from design, specification, nonconformity, manufacturing records. And we started ensuring that that data was curated, so basically structured, traceable, accessible. I mean, all of that is critical when you're using AI, right? And it's critical in safety critical manufacturing, but it wasn't necessary to produce it in that way, and especially if you're not manufacturing a safety critical component, you don't have to put in all that work because all of these good data quality procedures require work and require manpower, right? So we started doing that, and what we also saw is that AI was helping us organize this information at scale and extracting insights that would otherwise be difficult to obtain, plus improving our data quality. So, as I said, AI is like an extended statistics, right? Or mathematical application. And math allows you to see very well when there's an outlier. You know, you'll have a number of a cloud of points, and then you have an outlier, which you might not have detected any other way. But AI and statistics allow you to do that.
That's so fascinating. I mean, there's a lot, I know we're just scratching the surface, but that's what this podcast is supposed to be. It's just, kind of a scratch the surface, give an introduction. And also too, I wonder if you could say a couple words before our final question for anybody joining us now or later who is not familiar with the acronym ITER, which we say in our conversation, ITER. Can you say a few words about the huge multinational, consortium in the south of France that has been the pioneer for fusion energy research for the last several decades now. But some people, I mean, many people, I think, are still not familiar with it. So, a couple words about.
Sure. So ITER, or ITER, is the world's largest international experiment in nuclear fusion, and it's designed to prove that fusion can become a viable source of clean energy, right? Fusion is the process that happens in the sun where you, let's say, fuse or bind together two isotopes of hydrogen, namely deuterium and tritium, and you generate helium, neutrons, and very large amount of energy, and very, very large, right? So uh, actually, ITER also means the way in Latin. So it's symbolizing the path towards a new energy source, right? Many of the geopolitical instabilities that we have nowadays are due to energy, right? And so it is very important, considering that we have 400 million people in the world that don't have energy today, that we provide a clean energy source, right, as clean as possible, but that we also provide energy to these people, because at some point energy demand just keeps on going up and up and up, right? It keeps on increasing, and even more with AI. I mean, AI data centers require large, very large amounts of energy. So I often get asked, isn't it almost an oxymoron that you use AI to help fusion? I'm like, yes, AI will help fusion and fusion will help AI. So it's a win-win game that we have here, right? And in ITER, or in ITER, what we have is 7 domestic agencies, where the US, Europe has one, the Russian Federation, South Korea, China, India, and Japan are working together. Europe has 45% of the share, and the rest have 9. And we deliver in-kind components. So that means we either manufacture or do a little bit more from the design onwards. And so we deliver all these components. So you can imagine interface and requirements management can be a complex task. To then have the ITO organization assemble them together, basically like a puzzle, and build this very large fusion machine.
I love your explanation. Yeah, you touched on great points. You know, there really is a compassion that underlines fusion energy research that I think can sometimes get lost in all the technical parts of the conversation. And the compassion that you touched on there is 400 million people who are without energy. And then so many, the rest of us, so many of us now are facing escalating energy costs. So not to mention the geopolitical concerns that you also pointed to there. Look, we actually only have a couple of minutes left. We do have some guests, here who may want to ask some questions. You're welcome to raise your hand if you'd like to ask a question, or even just unmute. But I can lead off. Oh, there, I can lead off.
I have a question.
Yes, go ahead, Lars.
So do you have any favorite or general LLMs like, Claude or ChatGPT, or what do you tend to go to at ITER? Do you use specialized LLMs like CAD design LLMs? And do you develop your own custom models? Do you open source them? So that's kind of half a question. The other half is, do you have standard other codes that you use like Warpex or Blender or CAD Query? So just general question about the software stack.
Sure.
There.
Okay. I don't know if I'm going to be able to answer all of that in just a minute, but I'll try to give you at least the main ideas. So we do develop our own AI models, right? We also have commercial tools like Copilot, and there, you can select which LLM that you want to use. So within Fusion for Energy, we try to use European models so that we can also make sure that our data stays within Europe, right? And we keep that digital sovereignty. Then at ITER, obviously the game is slightly different, and we use all kinds of LLMs. We also develop some of our own, or let's say customize. And it really, I wouldn't say there's one size that fits all. I would say it really depends on what we're trying to achieve. So we're not going to use one of these very large and very heavy LLMs if what the task that we want to do doesn't require that level of accuracy, right? So we really target, obviously we try to make it as energy, let's say, as light on energy consumption as possible, right? And we really target what we want to achieve with that task. This being said, what we've tried to change recently is to go from a very customized development that could only fulfill the specific task that we were trying to achieve, you know, like an AI assistant, an AI chatbot for this kind of documentation or that kind of documentation, or this kind of correspondence, to trying to generate more general AI models that can kind of work like a plug and play depending on which data you're using, right? And to go on to the second part of the first question, so you were asking, are any of the AI models available? Some of our AI models are available from the F4E side on the F4E technology marketplace, and they're actually open to commercialize them. And they're specific. So, for example, for phased array ultrasonic testing, so PAUT, to process the data in just a couple of minutes instead of 1 or 2 weeks, right? On very long welds. Others are not yet available, but the plan is to make them available through small commercial licensing, basically, to industry and whoever needs them. What we do have is quite a few published papers, and we'll be doing more and more of that.
Oh, exciting. That good question, Lars. That really, yeah, that gave you a great platform to explain some of that. If we, well, we're at 22 minutes. I just, maybe the last 30 seconds, kind of a lightning question, and then we'll say thank you, and thank you so much for your time today, and for your participation yet again. Is what next for AI and fusion? And you don't have to give the whole broad answer, just like maybe the first thing, just a lightning question, what comes to your mind?
I think what next for fusion is part of the ITER agreement, right? What is really exciting is that we're seeing AI as part of the fusion world, right? So it's not something that is to make AI reliable and invisible part of how we deliver, right? It's more something that enhances our performance without adding complexity, right? So it's not just supporting ITER, but instead it's part of building the capabilities that will enable fusion, right? Because the AI that we do in fusion can also be used in fission, or it can be used in oil and gas. And we see a lot of this transversal, right? What we've seen is that AI was highly used in plasma science, which is the operations part of plasma, of fusion, right? But we've managed to, let's say, bring it in the earlier phases of fusion, so engineering and everything that comes before that, and even project management is something that we're exploring. So it's almost like the other way around, you know, the project kind of goes forward in a timeline, and we're bringing AI to the earlier stages of project. And I think the next phase is scaling, obviously, all of this, as I was saying, and building trust and robustness between the users and AI. These are communities that haven't always spoken to each other, right? And part of my work is exactly that, but showing that AI is not just a crystal ball or a black box where you plug things in and you get things out, but that it has, or it can have, the same level of reliability that an expert or that any engineering tool can have.
Oh, great. Wow, I love that. I love that answer. Yeah, I always learn a little bit more about, the facets of your position, and you're doing so many different things under wearing one hat. You're wearing many hats under one umbrella. Anyway, I want to thank you so much, Maria, for joining us again today, and thanks again to Fusion Energy Week organizers, and thanks all for you who attended today. And we'll make this recording available for the wider community to enjoy. So
thank you very much, Paige, for having me again. It was a pleasure.
Thank you too, Maria. All right, have a great day, everyone. Bye for now.
Thank you. Bye.